the area of the sector in the segment of a circle. This is a circle. If we join these, any of these, or make a region, this blue region, this is a minor sector, this is the major sector, and this becomes the major segment, and this becomes the minor segment. Major segment, minor segment. So this is the minor segment. This part is minor segment. This is the major segment. So once again, if I draw a circle, join any of these, we have two things we need to consider. First is your sector and then the segment. So this is your sector. First, you can say a minor sector. This is your major sector. And this major sector, apart from this, you have this, you combine this, means you just join this. This part is your minor segment, all other is your major segment. And we'll be interested more in the minor segment. So this, let us name, this is your R radius. Let us take this as theta, and let us take this AB as minor segment. We know that the area of the circle is pi r square, and the length of this, that is the fence, or you can say boundary, or the circumference perimeter, is 2 pi r. So what is the area, this shaded region, or you can say the length of this part or this part? How to find out? It's quite easy. We will use the unitary method like this. That is, for a circle, complete area is what? Pi r square. That is, this from here to here, if we go, we travel 360 degree. So for 360 degree, the area is pi r square. How about theta? For 360 degree, it is pi r square. For 1 degree, it is pi r square by 360. How about theta? For theta, it will be pi r square by 360 into theta. So this is theta by 360 into pi r square. This is the area of the sector. So area of sector is theta by 360 into pi r square, and this theta is in degrees. So you don't have to change. If it is given in degree, you can directly use it. Now again, let us talk about the segment, this part. Okay. Now this complete is 2 pi r. So if we travel 360 degree, the complete is 2 pi r. For 1 degree, it will be 2 pi r by 360 degree. For 1 degree. How about theta degree? Theta degree will be 2 pi r by 360 into theta. So theta by 360 into 2 pi r. This is the length, this APB, length of the arc of a sector of angle theta. So what will be this? This is 90 minus theta, 360 minus theta, sorry. So the length of AQB will be 360 minus theta by into 2 pi r by 360. Okay. And now if you want to find out this region, this blue region, what you have to do? This sector, the area of the sector of OAPB, that we already know, 3 by theta by 360 into pi r square. If we subtract this triangle, that is area of this triangle OAB, we get this region. We'll see how in an example. We'll try to find out. So in this way, the major segment, area of major segment and minor segment can be found out. You just have to subtract it, this pi r square, with area of minor sector and area of minor segment. So what we have seen, let us try to take certain example. We have to find the sector of the circle of radius 4. This is 4, and the angle is 30 degree. We have to find out the area of the corresponding major sector. So major sector. Let us see first method, then we have another method also. This is another method. This is quite simple, but let us solve by this method so that we understand various complications and the technique. So area of sector is what? We know this area of sector, theta by 360 into pi r square. Theta is 30 degrees, so it will be theta by 360 into pi r square. Pi we have taken as 3.14, r is 4 into 4. So 4.19. and the area of corresponding major sector will be what? The whole complete area is what? Pi r square. So if we subtract this 4.19 from pi r square, we get the corresponding major sector. So just pi r square minus area of sector OAPB, this one, we get the 46.1, that is the area of the major sector. One more thing, this is 30 degree. So how much this will be? 360 minus 30. Why can't we use directly here? Because this is of course theta. So we'll be using this 360 minus theta by 360 into pi r square. This is going to give you the area of major sector directly. 360 minus 30 by 360 into pi r square. R is 4. 46.1 as in the previous case. So in both the way you can use. Now you have to find out the area of the segment AYB, this segment, this blue region. If the radius of the circle is 21 and angle AOB is 120 degree. Angle AOB is 120 degree. So what we have to do is, if we have to find out this region, we have to find out the area of the sector first, and then we have to subtract this triangle from this sector. So the main thing is area of sector is we already know. Area of sector is this pi by 360, theta by 360 into pi r square. So theta is 120 degree. Just place it here. Theta by 360 degree into pi r square, you get 462 centimeter square. So this is the complete area. One thing is clear. Now we are left with the area of the triangle. Area of the triangle. So now let me show you how we'll make it. This is your triangle. This is 120 degree. We'll drop a perpendicular. This is 21. This is 21. So both sides are equal. So this angle will be also equal. This angle will be equal. So we have these two angles equal. These are 90 degree because we have dropped the perpendicular. Sides are already equal, and this is a common side. So these two triangles are congruent. Once these two triangles are congruent, this side, that is this region, this part becomes equal to this part, and this angle also becomes this angle. So this is 60 degree and this is 60 degree. So this is say x and this is x. Okay, so what we have to find out is half into base, that is 2x, into altitude, this h. This and this we have to find out. How we are going to find out? See, it's quite easy. We have known that this is 60 degree, 60 degree. So you can just use cos 60 because this is known. Cos 60 for this is base, means OM, by hypotenuse AM. OM by AM. OM we have considered to be x. So x by 21 is half. So x becomes 21 by 2. This is 21 by 2. This is 21 by 2. Both becomes 21. Right? Again, if you want to find out the this side, no worry about that. What it gives you, OM is 21 by 2. I'm so sorry. This is 21 by 2. This is not 21. We have to find out this. So sin 60, take perpendicular by hypotenuse. Perpendicular is this. Hypotenuse is this. Perpendicular, hypotenuse. This by 21 means AM by OA 21 is sin 60. That is root 3 by 2. So AM becomes 21 root 3 by 2. So this becomes 21 root 3 by 2. This becomes 21 root 3 by 2. So these together becomes 21 root 3. So this is 21 root 3 and this we just got as 21 by 2. Now we can directly apply half into base into altitude, that is 21 root 3 base into altitude. Altitude is what? This is 21 by 2. This is what we have done. So area of triangle is this. Now we just have to subtract 462. We have already found out this complete area. We have just found out the triangle area. So we have to subtract so that we can get this. So this is how we get. We subtract 462 from this, and this is your area of the segment.